Hello, good morning everyone. Welcome to the 20th edition of the ECOSYSTEX Insights Series in this beautiful 6th of March. It's a sunny day in Brussels. I hope you're having a good day as well. While we're waiting for people to arrive, let me already share some webinar procedures with you. So as you know, since maybe you're joining these webinars already for some editions, this webinar is being recorded and will be shared on public channels. And by, staying connected, you agree to this. All your cameras and microphones are disabled besides the one for speakers. So if you have any questions, please do always type them in the chat, mentioning who they are for. And if we should have some extra time, you can also raise your hand if you wish to speak, and then we will give you the rights to also enable your camera and your microphone. So that's, business as usual, I would say. Very briefly, for the ones that join us for the first time, well, my name is Tilla Cross and I work as Sustainability Programs Manager at an organization called Textile ETP that is organizing these ECOSYSTEX Insights Series. Who are we? We are the largest community of research and innovation professionals in Europe. We're Brussels-based organizations, and we collect members from all across Europe. Could be universities, clusters, companies, all working on research and innovation in textiles. And we organize different activities and services for our members. So of course, as a network organization, networking as one of our core activities and bringing our members together. We also have different learning formats where we invite expert speakers to, speak on different topics and others can learn from them. We have a smart and high performance innovation hub, a circular and bio-based textiles innovation hub, and a digitalization innovation hub. And then, of course, also this ECOSYSTEX community that you'll learn more about in the next slide. And thirdly, one of our core activities is also to bring our members together so that they can form consortia and then apply to EU funding, as we're also the lead organization to represent the private sector in the Textiles of the Future partnership under Horizon Europe. So that's broadly what we do. My colleague dropped the link in the chat if you want to hear more about us in case you don't know us well yet. Maybe because you're, a textile sustainability interested audience, a few more details about our circular and bio-based textiles innovation hub, which is, focused on these topics. And we're working this year on developing a bioeconomy innovation strategy for the European fibers, textiles and apparel industry in different co-creation workshops. So that might be really interesting for some of you people here. And the first one will be on the 26th of March. So if you want to contribute to that, the aim of this strategy is to open new EU funding opportunities and engage with related sectors in the field of bioeconomy. So do have a look at this innovation hub as well. Now, let's move to the next slide. This is the agenda of the webinar here today, the 20th ECOSYSTEX Insights Series. We will start with, a few introductory words from my side that are currently running, and then we have two project presentations, one from the Hemp for Circularity project that will present its final results. Then the TRUSTex consortium will share what they've been working on so far. Afterwards, we have some time for questions to the first two projects that you can type in the chat throughout. And then in the second half of the webinar, we have two more project presentations, one from the VERDEinMED consortium that is also finalizing its project this year. And the last but not least presentation will be from the live POLITEX project. Again, time for Q&A with the audience. And then in the end, I'll wrap up and share some upcoming activities from our member projects. So very briefly, just to so that everyone here is in the loop, what actually is ECOSYSTEX and this community that we bring together? Well, ECOSYSTEX is the European Community of Practice for Sustainable Textile Ecosystem that ETP launched in January 2023. So we've been running now for over 3 years and bring together over 85 member projects. And out of those 85 member projects, over 470 experts registered to take part in our different activities. What are our activities? Well, we want to foster inter-project collaboration, so bringing the experts across the different consortia together in different working groups. We have 8 different working groups for that. Occasionally, we also engage with EU policymakers because there's a lot of scientific expertise here in this ECOSYSTEX community. So we forward that to them to inform their decision and policy making. And then we're also very active when it comes to project dissemination and supporting our member projects well with disseminating and communicating about their results, because there's a lot of interesting output, as you'll see in this webinar. So we have different dissemination activities like our webinar series, but also an annual conference. Here on this slide, you can see all our member projects, and these are the ones that we'll present today. So without much further ado, I'll invite the first speaker of today, Sofie Vermeire from Horgend, to take the floor and share with us what they've been working on in the Hemp for Circularity project.
Good morning, everyone. I'm Sofie, and I work as a researcher at Horgend for the research center FTE Lab, stands for Fashion and Textile Innovation Lab. I will tell you today a little more about hemp. In the FTI Lab, we is a research center within Horgend, the University of Applied Science, and we focus our scientific research mainly on bio-based materials such as hemp, and conduct research into textile processes with a low footprint. Our focus is also on the comfort of textiles and the protection that they can offer within specific applications, as well as e-textiles and digitalization. The FTE Lab can help you with prototyping, pilot productions, and process optimizations. So we have the equipment for fiber preparations up to and including ring spinning for short fibers. We have infrastructure for knitting, weaving, embroidery, and finishing textiles by dyeing, printing, coating, laser, or embroidery. And recently, we have also for mechanical recycling. Hemp for Circularity is an Interact project that aims to implant an innovative, local, and bio-based ecological fiber, the long fiber hemp, in the textile value chain of the Northwest Europe, from growers to weavers and knitters, from field to fashion. The project set up pilot actions at several stages of the value chain, from cultivation, primary processing, data-driven farming, spinning, fabric production, to optimize all stages of the production in order to be a durable implemented from fiber to recycling solutions. With this project, from field to recycled fiber, hemp is a driver for circularity in the textile industry. The project aims to bring opportunities to the farmers, the flex sector, the textile industry in general, and the brands in demand for local and sustainable materials, and the end users. Hemp is one of the oldest cultivated crops. Its histories go back more than 10,000 years. In our region, hemp was at its peak from the 15th to the 19th century. The first books were printed on hemp. Hemp was used in ship sails and ropes, and the word canvas is derived from Cannabis sativa. However, around 1937, hemp cultivated was banned, first in the US and then in Europe, due to its negative image. Another reason for the decline is the rise of the other fibers, such as cotton and the synthetic fibers, and the high labor cost of the hemp processing. Since the early 1990s, hemp cultivation has been permitted again in Europe. The process from hemp plant to finished fabrics consists several steps. The most important are cultivation, scutching and hackling, spinning and weaving or knitting, and afterwards the textile fabrics are further finished, but later more. Hemp is sown between the end of April and mid-May in a moist and warmed soil. Hemp is a fast-growing crop. The plant can grow 3 to 4 centimeters per day and can be harvested after 80 to 100 days. Early varieties flower at the end of July, beginning of August, and are preferably harvested during that period. At the end of the flowering, further growing length stops and the development of secondary fibers starts that have a lower quality than the primary fibers that are produced until flowering. After harvesting, hemp remains on the field for another 4 to 6 weeks to rot, so that the bast fibers loosen from the wooden core. During this field rotting, microorganisms from the soil break down the pectin in the stems and make it easier for the fibers to be mechanical extraction from the stems. The swaths are turned 1 to 3 times. The rotted stem straw becomes pressed into round bales. During the project, we used a harvester from Heiler, a partner in the project. The harvester can process the hemp stalks up to 3.5 meters. The stems are divided in 2 parts and then placed in separate swaths on the field. The harvester has a capacity of 25 hectares per day and has an automatic ground tracking system. For the next process steps, turning, baling, scutching, we can reuse the machines available for the flax. This video shows you the breaking and the scutching of the hemp stalks at Van de Bilt in the Netherlands. During this process, the 2 types of fibers are separate, the long fibers and the short fibers, as well as the byproducts, including the sheaves and the dust. The long fiber yield is influenced by the growth and the rotting conditions on the one hand, and the quality of harvesting on the other. A wood hemp bale is dry and has about 50% of moisture content. During these different project years, the yield of straw and fiber is very different for the 4 countries. Not all partners have the same level of experience with cultivation. From economically point of view, the cultivation of hemp for long fibers is positive. Scutch fibers is divided into classes by Sofie. A visual assessment of the hemp fibers is done on 4 parameters: the number of sheaves still present between the fibers, the numbers of fiber bands sticking together, the color, and the length of the hemp scutched. Xavier made a visual assessment of the scutched fibers in the FTI lab. We tested the fibers as described in our protocol. I give you some results of the cultivar year 23. The fiber bundles does not show too great difference between a lower and the upper parts of the stems. The results can be seen for the cultivar the Uso 31 and the Santica 27. The fiber finance, on the other hand, is very different. In the top of the stems produce coarser fibers. The tenacity, the tensile strength of the fiber bundle in relation to the fiber fineness shows a good result. In the graphs on the right side of the slide, you can see the color difference. There is a slight color difference visible, namely the fibers on the top are slightly darker, that you can see on the lower L value. After a chemical analysis with the VERDEIMED, we can determine how much the content is of cellulose, hemicellulose, and lignin. Most of the pectina has already disappeared during the felt treating. The fibers from the top of the USO 31 have a higher proportion of lignin, which is disturbing for the further processing. A SEM analyzer combines scanning electron microscope with energy disperse X-ray spectrophotography to visualize the surface morphology and identify chemical compositions in solid materials like our hemp fibers. Operating in a vacuum, it provides high-resolution images, and we can measure the amount of metals, polymers, and coatings on textiles. In the graph, you can see the influence of the presence of calcium before and after demineralization of the scratched hemp fibers. The final test on the scratched fibers is to determine the pure fiber content with a TRUSTex analyzer. The hackling of the scratched fibers is done in several steps. All these steps are carried out one after another on the hackling turbine of flax. The hemp bales are opened and the fibers are fed into the line. During the hackling, the fibers are repeatedly pulled through fine pins to remove the lost sheaths and separate the short fibers from the long ones. First along one side and then to the other side of the bundle. The hackled fibers overlap and further refined into a hackled sleever. The hackled sleever has a small twist and is finally packed into bumps for the spinning mills. Due to the good results of the scratched fibers of 2024, the yield of the hackling was 63% compared 54% for 2023. The harvest of 2024, no sheaves are left after scratching. Certain lots have no bands, some have a few bands. The color was very uniform and the length is between 50 and 150 centimeters. Sofie expects that it will be possible to spin a yarn with these fibers between a metric 26 and 30. Compared to 2023, it's a very good or better quality. The spinning of hemp is done by the project partner Sofie. So multiple hackled sleeves from 23 and 24 are combined to obtain an uniform yarn quality. They are after combined and lengthened through the use of a drawing frame. Therefore, 6 hackled sleeves pass through a drawing frame and leave the draft together in one sleeve. These sleeves are further mixed together. The fibers go at least 4 times through the drawing frame to achieve a roving with a consistent quality and with a correct weight for the spinning mill. The sleeves are further refined and wound on bobbins. These bobbins are balled and or bleached and then go back to the spinning mill. The bobbins are still wet and are wet spun. While spinning, the rovers also run through a warm water bath. The yarns are twisted onto the small blue spinning spools. A ring travels around the spinning spool at a high speed. It moves ups and downs and guides the yarn along the spool to ensure an even distribution. The spindle rotation gives the yarn the correct torsion, and this way of spinning results in a smooth yarn with a permanent shine. The small spools are collected and dried in an oven before rewinding into large bobbins for the weaving mill. The yarns are not knotted together, but brought together with splices. In this presentation, I will give only the results of the yarn number metric 12, what we used in our first fabric, because this yarn had the good properties. During the project, we also produced other weaving yarns numbers and also a knitting yarn in number metric 18. So the yarn has a tenacity of about 24 centinewton per tex, or a tensile strength of 20 newtons, which is enough to use the yarn for weaving in warp. The yarn has a low elongation at break as a result of the wet spinning. With the evenness tester, we could determine that the yarn still has many thin places, more than 2,400 thin spots per kilometer, which means that the yarn can break regularly during weaving. The naps in the yarns ensure that the fabric has less smooth surface. The hairiness of the yarn is low and is about 3.6. In the diagram of the irregularity, you can see a recurring area at about 10 meters. The hairiness diagram shows you a normal distribution. The results of these yarns are the results of the yarns from 2024 and 2025 will be better, because in the meantime we have more experience, and all these results are for the end of the year. The preparation for weaving includes a sectional warping. The weaving beam is done in 2 steps. So we took 23 bands of 90 warp threads and wound on the large rotating roller of a sectional warping machine. Afterwards, the yarn of a filled warping machine is transferred to a warp beam located at the back of the machine. During the filling of the warp beam, wax is applied to the yarn to facilitate weaving later. For the project, Libico, also a project partner, made a weaving beam with a width of 190 centimeters for various tests. The weaving is done on a rapier loom with a speed of 220 wefts per minute. The same yarn was used in weft as in the warp for the first fabrics. So the fabric had then a density of 40 wefts per centimeter and 13 warp threads per centimeter. The weave has many reed stripes after weaving, and this will disappear during the finishing. The fabric directly from the loom is called loom state. In order to use the fabric later for dyeing, the fabric is made ready to dye, and this process consists of several steps, such as desizing or removing the applied wax, demineralization or removing iron and other inferior minerals. Before bleaching, boil off is done with soda. 2 times bleaching is done with peroxide to obtain a white fabric, and the fabric is finally rinsed, neutralized and dried before dyeing. The ready to dye treatment gives the fabric a nice surface, and now it's hydrophilic, which makes it possible to perform a good and even dyeing. By performing an analysis with the VERDEIMED, we can see the influence of the concentration of cellulose, hemicellulose and lignin on the hemp and other plant fibers. In the dark blue, you can see the average value of force-cut fibers. In the pale blue, you can see that the lignin has almost disappeared due to bleaching before wet spinning. And because of the ready-to-dye treatment, the lignin almost disappeared completely. The higher the proportion of cellulose, the better. The pectin has already disappeared during the field threading, and a residual pectin can be demonstrated by a ruthenium road dyeing. One of the most common used methods of dyeing cellulose fibers is cold batch with reactive dyes. The fabric is immersed in a bath with dye and alkali. Afterwards, the fabric is rolled up and fixed for several hours. For the test in the FTI lab, the samples were washed out the next day to remove the unfixed dyes and to obtain a good fastness. A cold batch dyeing ensures a nice dye with a wide range of shades and a color's depths. These photos on the left are dyed on an industrial scale on fabric with yarn from Lambrecht. And the photo on the right shows you the difference of cold babach on loom-state. The warp was balled yarn and the weft was bleached compared to a ready-to-dye fabric. Hemp fibers are very strong and stiff. To make the fabric soft, we tested a lot of softeners and different chemical base and different suppliers. And one of the best is an alkaline ammonium compound. To use the softeners give you also a better abrasion resistance to the fabrics. A smoother surface provides this. With the taper, we tested the flexibility of the fabric. On the picture, you can see the difference between an untreated and a dyed fabric with a softener. We recently got a shredder in the FTI lab, and the first hemp fabrics have been mechanical fiberized. In the coming weeks, we will continue to optimize the parameters so that a good fiberization takes place and it can later be used for spinning new yarns. We will show the results of the hemp recycling in the FTE lab on May 21 in the afternoon, and in the evening we organized the annual Textile Network tech stream with a focus on recycling textile. You are very welcome in Ghent in the FTI lab for the workshop or for the tech stream events. Thanks to our partners, and hopefully hemp will become a local and sustainable fiber for textiles again. If you want more about the project, feel free to send an email, chat, or follow us on LinkedIn. And thank you very much for listening.
Thank you very, thank you very much, Sofie, for your presentation and taking us through everything you've done in the past 4 years, or well, giving us a good overview at least. Thank you for that. And yes, I mean, do take the opportunity to ask questions to Sofie in the chat for the Q&A. While we now move to the second presentation of this first half. So I would like to welcome Ghaya and Xavier-Francois from the List Institute in Luxembourg to take over the floor and share first results from the TRUSTex project.
So good morning to everyone. So today my name is Xavier Verni, so I work in the Luxembourg Institute of Science and Technology, and I will present you the first results of the TRUSTex project together with my colleague Ghaya. So just to start, to give you an overview of the project TRUSTex. So the TRUSTex project is an Horizon project of around 7 million of euros plus additional Swiss funding. It's the project started in January 2025 and will last 3 years, so till end of 2027. We have different kind of partners, so RTO, university, NGOs, large industry, and also small and medium enterprises. And on the screen, as you can see, we have around 19 different partners, and List is the coordinator of the project, and I am the project manager. And you can see also the structure of the project with all the work package. So concerning the different areas of what we are doing under TRUSTex, if you looked at the third column on the screen, you can see that we are working on the testing and proposing circular strategy, developing recommendation to shape the future EU EPR, looking at best practices on EPR governance, looking at eco-modulation fee, eco-design requirement, traceability through the DPP, but also looking at innovation, looking at how to optimize collection, sorting, reuse, and also recycling. And also we have a part looking at engaging different stakeholders. So to briefly mention today, so the agenda, so the today's presentation will cover different findings. So we will cover 3 different topics. So baseline and EPR research, impact assessments, where we are in terms of environmental, socioeconomic impact, and also what we are doing in the circularity strategy and innovation. As you can see on the slide, you have we've published a lot of deliverables now, and you have directly in the slide the link to download and to have a view on the different deliverables that we have published. So all our deliverables are published on our website, so you can find also the link on the bottom right to go directly and to download all our deliverables. So now move on to the first topic. So I will hand over to my colleague Ghaya.
Yes, thank you so much. And as Xavier said, here we're representing our partners and the consortium. So we will be presenting some of their results and the findings that so far have been achieved. And I will start with the following flowchart prepared by our partners to visualize the current textile system. But first, one of the key questions they checked is why does the textile supply chain remain structurally linear? And some of the reasons could be related to the production volumes that continue to grow faster than our circular capacity, the distribution models that are optimized for speed and price, but not durability so far, the consumer demand that still reinforces short product lifetimes, and end-of-life systems that are under serious pressure because, of course, the volumes keeps increasing, the product quality is declining, but also the fiber complexity can make the recycling difficult and expensive. Now, looking at the flow chart itself, you can see the journey, but I will not go into all the details. In an ideal circular economy, the products would flow towards the reuse, refurbishment, and the remanufacturing, keeping the material in a closed loop, ideally within the same market. However, what we see is different. The material flow into open loops and the recycling into other markets. And there's also too much ending in landfills, incineration, and or simply lost. As a result, the system can look like where circular loops exist, but they remain small compared to the linear flow. Our partners have also worked on comparing linear versus circular system to identify the barriers and the improvement pathways. Here is a brief representation of the main weaknesses, strengths, opportunities, and the threats in both systems. And again, I'm sorry, I will not go into all the details, but I will briefly deep dive into some of the threats of the linear system. And as you can see in the orange part of the slide, the regulatory pressure from the EU textile strategy and other policies can be a threat for the linear model, but they are also part of the strength of the circular model highlighted in green. And this is because it can implement or force the change because based on the different policies and EU policies that, especially when aligned, it can create opportunities and drive innovation in design, sorting, and recycling, and of course enable new business models, right, like resale and repair. And from this, I can also present the work done to put under the analysis of regulatory landscape. And as mentioned, the full work is published already in our TRUSTex website, so you can go look into the bigger picture over there. But in this slide, we have summarized the interplay between the two key regulatory pillars shaping the circular economy for textile. On one side, you can see the ESPR that harmonizes market entry by setting mandatory product performances and information requirements. And on the other side, there is the EPR schemes under the Waste Framework Directive that can be implemented at member state level. There is an interplay between these two pillars which are designed to converge. The information from ESPR digital product passports, for instance, provide the necessary data to calculate EPR fees. Likewise, the ESPR performance requirement directly informs the EPR eco-modulated fees, rewarding products that are more durable or recyclable. So the core message is this: the stronger the alignment between these two mechanisms, the greater their collective impact. And together they can create a powerful system that drives innovation, enhances the market surveillance, and ultimately delivers on the environmental and economic goals for the circular economy. We have also looked at the different EPR schemes across the member states, and here are some of our findings after analyzing and comparing existing EPR schemes. About the scope, it can be very broad but uneven. So all schemes cover clothing and household textile, but the product definition vary wildly. Some include footwear, accessory, or leather. Other explicitly exclude them, but also can some include even occupational textile. When it comes to the fees, the weight-based fees dominate. Eco-modulation, however, is emerging, but unevenly. The targets vary significantly by country and by category. As you can see from the presented figures, the percentages are very different from one country to the other. So in general, EPR schemes are innovating, but currently still fragmented efforts, and this can create the complexity and shared thoughts. Under the analysis, we've also looked at governance across the member states, and here we can list, or we can say that we see several systemic weaknesses. There is too much focus on downstream waste management rather than upstream prevention. Binding measures on eco-modulation and repair are still missing. Cross-border compliance loophole persists, like online sellers often escape obligations, and authorized representative requirements remain inconsistent. There is also a major export blind spot, where EPR stops are at the border, meaning that traceability is lost once the textile leaves the EU. Also, data and transparency gaps blocks the progress, especially when it comes to weight-based reporting and lack of machine-readable data, making the eco-modulation and alignment with the DPP difficult. However, there is still an opportunity through harmonizing, which is in progress, let's say, in governance and in reporting EU-wide. Also with closing certain loopholes and upscaling best practices from front-runner countries. We have also presented a few policy recommendations in the different tasks or work we have done. And to mention a few, there is a need to align policy, policy, especially to strengthen the triad waste framework directive, ESPR, DPP, linking the EPR with the Green Deal objectives, harmonizing criteria across the EU in order to create a level playing field. But of course, ensuring inclusive governance and consumer engagement by also including all stakeholders in decision-making, and without forgetting enforcing or supporting stronger accountability. There is a need for supporting consumer awareness campaign and real-time chemical traceability. Also, a recommendation to mandate strong eco-modulation, linking directly to eco-design performance, rewarding durability, repairability, and recyclability, which is also being done under the ESPR currently. Using DPP and unique identifiers as a data backbone, but also fixing data and traceability, because currently the reporting might be still fragmented. However, the EPR should support harmonized reporting across the EU. And then creating incentive value retention before recycling. So to follow the waste hierarchy and prioritizing reuse and over-recycling, allocating parts of the EPR funds to repair network, reuse infrastructure, sorting facilities, and And of course, there is a need to monitor KPIs, but also to not only focus on recycling only KPIs, but also prioritizing preserving product value through repair and reuse. This also, of course, by tackling all overproduction and closing loopholes, as already mentioned, and of course, addressing legacy textile to use EPR funds for take-back schemes, for example, and reuse programs. So these are quickly mentioned some recommendations. Some of them have been already implemented through the different updates in the SPR and in the policy. But it's still useful to mention them. Moving forward, I would like to bring some focus on the textile approach to eco-modulation, or sorry, our TRUSTex approach to the eco-modulation. And according to our partners, the challenge is simple but significant, where most current EPR fees treat all textile the same, regardless of the durability, recyclability, or chemical safety. This provides no incentive for better design. And to solve this, our approach introduces the trusted eco-modulated equation. You can see it on the right side of the screen. So think of it as a tool that translates circular economy principles into economic signals. These signals should reach back upstream to influence designers and manufacturers. For looking at the textile journey for every stage, from raw material to design to the distribution, we've identified eco-modulation hotspots, and these points where a fee can be adjusted to reward positive choices like using safer chemicals or designing for recyclability. The equation itself is a vessel that can make this work, and without getting lost in all the technicalities, what we can say is the core component of this trusted equation are the necessary costs, which can cover the end-of-life handling, the surcharge cost, which penalizes problematic material or designs, and crucially, an eco-design bonus, which provides a fee reduction for products that demonstrate genuine circularity, like durability or non-toxicity. The equation also protected by an inflation adjustment factor, ensuring that the incentives remain effective over time. So in essence, this model moves us from flat fee to an eco-modulated fee that rewards the responsible actors and creates a financial rationale for investing in circular design from the very beginning. Yeah, and the next slides, we will go into the impact assessment analysis, especially the environmental and the socio-economic. You're muted, Xavier.
So now I will present you two different topics concerning what has been done on the TRUSTex. So one part will be on the socio-economic impacts and the other part will be on the environmental impacts. So all this research is based on literature research, on grey and academic literature, and focusing on the topic on workers' wages, livelihoods, and working conditions. So the presentation on social economic impacts will be divided in three categories. First, a view on the global value chain, then on the EU circularity, and finally on Africa circularity. So concerning the global value chain, what we can say is that apparel production has a big impact in global employment generation. However, the vast majority of workers are paid extremely low wages, and high levels of informality mean that many are excluded from discussion on sustainability transition. Considering the deep interconnection between environmental and social issues, substantial progress in the industry requires structural change rather than incremental adjustments. For these reasons, in terms of solutions, what might be put in place is that legislation aimed at sustainability in apparel supply chain should incorporate workers' voices in order to adequately understand and promote well-being for all stakeholders involved. Now moving on to the EU circularity topic. So also focusing on impacts on worker wages, livelihoods, and working conditions. As already mentioned by Ghaya, the main problem of the textiles industry in EU is overproduction and overconsumption. Can the circularity be the solution? Yes, but policies should incentivize waste prevention rather than waste management. And how to build this truly just circularity is trying to design reskilling programs for workers displaced by structural supply chain changes mandated by policies, promote degrowth business models to avoid that profit maximization pushes workers adrift from unions, include actors from the social economy to engage with the marginalized and vulnerable in the economy. Now moving on to the Africa circularity. So I would like to mention that Africa receives around 35% of all global worn clothing exports. 90% of the population depends on second-hand clothes across the regions. Second-hand clothes waste statistics are contested, 5% versus 40%. And what might be the solution, or could be the solution, is to have an inclusive consultation and integrate informal workers, build local circular ecosystems, but also raise public awareness and consumer change. Now moving on to the environmental impacts. So these first results are based on the literature of around 33 documents. So the first results concerning water and raw materials consumption is that the textiles industry is the second largest consumers in terms of water, and over 99% of the 30.25 billion tons are coming from virgin sources. Concerning the point regarding the circularity, at the moment, only 0.3% of the textiles industry is circular. And as you can see, according studies, 87% of the clothes produced globally each year are landfilled or burned. Regarding the manufacturing, we can say that dyeing, textile formation, pre-treatment process are really key environmental hotspots with other topics. Regarding the reuse, what we can say is that the reuse of 1 kilogram of clothing could save up to 25 kilograms of CO2 equivalent emissions. And if we're looking at the transport impact, we can say that the environmental impacts of transport in reuse scenario remain negligible. Now moving on to other aspects of the literature review concerning environmental impacts. So concerning the methodology used to calculate the life cycle assessment, so the deliverables identified different methodology, among them the PFCR that covers around 7 key environmental impact categories. There are other methodologies that cover other categories. One of the methods that is oftenly quoted is the recipe, and the main database is the EcoInvent database that is being used. Concerning the information concerning the microplastics impacts, what we can say is that the majority of the microplastic from textiles are released the first few times textiles are washed, and there is no general difference between fabrics made from virgin polyester compared to recycled polyester. So now concerning also the subject of substance of concern, what we can say is that at the moment in the literature review, we have identified up to 3,500 hazardous substances that could be used in the production. And we are also working on another input, looking at the TRUSTex list of potential substance of concerning textiles under the ESPR regulation. So now moving on also of what has been done under this environmental impact assessment. So we have also found some eco-design insights, such as switch to natural colorants, prefer technology that reduce resource reuse, adopt eco-friendly techniques, and so on. So I will not go in deeply in all these kind of recommendations because you can see them in the deliverable that is published on our website. So now moving on to the last topic, circularity strategy and assessment of separate collection strategy.
Yes, given that I think we took enough additional time, I will not go into all the details, unfortunately, for it's an interesting part of the work my colleagues are doing. But I will mention that in this innovative or circularity strategy work, there's different pilots that are being included, especially eco-designed fibers, semi-automated sorting for use, disassembly of eco-design products, and next-gen sorting technology. All this is gonna be implemented in different use cases. We have identified here 2 use cases which will be real-world demonstration of eco-design principle. We have and these products like the jeans and the trekking jacket that will be developed under these use cases are going to be used to support the sorting, disassembly, and recycling pilots in the work package. Also, there is some work that is being done to assess the separate correction strategies, and without going into the details, our partners have analyzed different contexts, and their main message is that there is no universal best system for collection. It is the performance is context dependent, and the work is that could be done in, for example, in an urban district cannot be implemented in a rural area. The partners are also offering a structured starting point with context to configuration bundle that can help tailor design choices. And on that, they have a design checklist to choose context type and to align the channels, quality control, EPR incentives, and minimum strategy. Yes, unfortunately, I would have loved to go into more detail because the work is very impressive in here. However, yeah, I think we're way too over time. I will just take one extra minute to say that we would love to have your input on what has been presented, to have your perspective. We have prepared this survey. So please, if you have some time, take a bit of time to answer some of these questions and give your feedback on it. As a reminder, and we have also included it in the different slides, these are the contact of our colleagues in charge of the different topics. We have also included the link to our website and to our newsletter as well as our LinkedIn. I would thank you from my side, and I apologize for the delay. I think if Xavier would like to say a last comment.
No, just no other comments. Yeah. So
yes, thank you so much.
Thank you, the two of you, for your taking us through all the work you've already done in the TRUSTex project. Really, really interesting, and I think many people here appreciated what both the two of you and Sofie shared so far. Yes, as you mentioned, we're now a bit behind schedule, but I still
sorry about that.
Yes. It happens. It happens. We'll have you back in another webinar to go into more detail about about everything. Nevertheless, I want to quickly maybe take just 2 questions, one to Sofie and one to you. Sofie, there was a question to you from Stefan. To the part about spinning of hemp fibers. You mentioned wetted sliver applied to ring spinning and drying the crops after spinning. Does spinning need special ring spinning equipment, or is it possible to apply a machine based on standard long or staple spinning frames?
We are speaking about wet spinning because the fibers are wet, so that's a little different of what we say, the spinning of synthetic fibers. So our fibers are wet during spinning, go through a warm bath with water, that they are really, really wet. And then the principle of spinning, of rinse spinning, if it's a short fiber or long fibers, it's almost the same. Yeah, it's just because of the length of the fibers from flax and hemp, or 200 to 250 millimeters instead of a cotton where it's 36 millimeters. So then is a small draft. So if you be creative and then make a bigger draft, then it's also possible. There's no big difference between rinse spinning, short fibers, wool fibers, only that we start from wet fibers. We make them wet, we doesn't dry after bleaching or after boiling. And yeah, the drafts, the middle part of the spinning is depending of your fiber lengths. Yeah. And then because, yeah, of the wet spinning, we have to dry to make it a little easier in the weaving after. Yeah.
Okay, thank you.
But I will send also an email to Stefan. I know him.
Okay, yes,
okay.
Great, perfect.
Yeah.
Nice. And then a question to you, Ghaya and Xavier, from Ese, I'm definitely not pronouncing that right. Can you share some examples of how policies can support waste prevention rather than management? Could reuse be supported by this?
To my understanding, under the Waste Framework Directive that will set up the EPR for textile, for example, there is some requirements, and there is also the fact that we have to follow the waste hierarchy. So it means prevention. So it means that some of the eco-modulation fees or fees that will be then collected with the EPR implementation could then be invested in this area of trying to go more for waste prevention in terms maybe of communication to the consumers and so on. So this is also a way, with the fee that will be collected under EPR, it's a strategy to know where you put the money. And one part of the money can be put on the waste prevention because it's really clearly mentioned in the Waste Framework Directive. So
okay.
it's also the will of POLITEX to go for that and to stress that these fees can be allocated more on the waste prevention than waste management.
I see. Thank you for your answers. There's one more question to you in the chat, but maybe you can answer that in writing, actually, because we're we're a bit over time and we still have 2 more interesting presentations coming up. So thank you for the 3 of you for the first half. And now I would like to give the floor to Valantis Ketikidis from South in Greece to share what they've been working on in the VERDEinMED project those past years.
Thank you, Tilla. Hello, everyone. My name is Valantis Ketikidis. I am a research associate at CERT. And let me share my screen. Just a second. Okay. Well, let's introduce a little bit the project itself and then focus a little bit on one specific activity, which is the support service. From strategy to practice, VERDEinMED's technical assistance service. So the project is a territorial cooperation project. So we are talking about Interreg Euromed. It's a 2.5 years project, or 33 months with a reporting time span. And here are the project partners. So we have a well-balanced Mediterranean partnership from Portugal, Spain, till Greece and Bulgaria. What is VERDEinMED doing, and what are the focus areas? First of all, the title, as it suggests, we are focusing on preventing and reducing the textiles waste mountain in the Med area. So our focus areas are to analyze, first of all, the textile value chain in each country, to develop tools and pilot actions for sustainable practices, to engage consumers, industries, and communities, because it's a project which has a holistic approach. So everyone is included in this endeavor. To promote sustainable production and consumption, to implement textile waste reduction and recycling strategies, as just mentioned by TRUSTex, and to deliver policy recommendations and also communication campaigns. So this is in a nutshell what we have done, or the starting point of this project. Let's focus on 4 areas on our tools and our activities. So starting with the knowledge sharing and co-creation approach, we had a conceptual framework for information sharing and co-creation through our own knowledge platform and our own community of practice, the VERDE. So we have prioritized topics which will be illustrated on our knowledge platform, and these topics have been discussed or are currently being discussed in our VERDE hubs. We have a support service. It's a technology transfer and knowledge exchange through launching and testing a support service to industry, civil society, and policymakers. So the technical assistance service, which will be just presented, is within the industrial support service. Then there is a support service to the civil society through living labs and consumer awareness campaigns. And there is also one support service to policymakers through a VERDE Academy, which is a policy-oriented community of practice, which is also accompanied by some study visits to various industrial partners or to industrial applications. Going further, we see the VERDE Bussola. This is a framework to establish regional knowledge and competence centers, which will integrate and consolidate what has been done or is being done currently in the project, meaning the VERDE hubs, the community of practice we have, the knowledge platform, and this support service just presented to you, and everything is consolidated in one single entity, one-stop shop, let's say. And we will conclude with strategies, regional or national strategies, which is not so easy, as you know, and policy recommendations on a local level. So this is in a nutshell the project itself and what we have done. And now let's focus a little bit on the support service. So the support service is about a technical assistance service to industrial partners. And when we are talking about industrial partners, we are talking about the small ones, micro companies, SMEs in any case. So this is a mentoring program which is aimed at supporting, of course, the textile-related enterprises in order to address their sustainability and circularity challenges. So we selected external mentors, and we selected also beneficiary companies. And the procedure was very simple. We followed a partner-led matching process. So partners assigned specific mentors to specific companies based on the profile of each mentor and based on the specific needs of each company. So the criteria were specific needs, asset, expertise, and of course the areas of intervention. And we will see later on what kind of intervention we had. On the methodological note, we have to see the methodological approach. It combines quantitative aggregation and qualitative thematic analysis. So you have a lot of cases where you had mentors, where you had companies with specific needs, and it was very, very difficult to cluster and to aggregate and to cluster some results and some impact there. And let's see further on if we succeed in that or not. So from the methodological point of view, we had quantitative data derived from structured and closed sections of individual reports, which were delivered by each mentor and endorsed by each beneficiary. And then we had also qualitative information from open-ended sections in each report. So here you see some snapshots of fact sheets which were prepared based on each mentoring report received. Just 2 examples, and those will be uploaded on our knowledge platform as soon as the mentoring reporting process is over, and this will last 1 or 2 weeks more. So if you notice this link here, then you will have access to all the reports. Well, we had, as said, 37 mentoring cases across the 7 territories. The mentoring process was delivered either on-site or in a hybrid mentoring mode. Most of the cases were online. You see here the number of cases per country: Italy, Spain, Greece, Northern Macedonia, Bulgaria, Slovenia, and Portugal. And this is a packed slide with a lot of information. This is the mentoring cases covered with information about each mentor and about each mentee and the sector and focus area where the mentoring was necessary. So you see here, once again, we focus on small and medium-sized enterprises, from very small, from micro enterprises with 1 to 3 people, which have one kitchen and are cooking there or dyeing in their pots, until one larger company, which was placed in Spain. Just to give you an overview about the sectors or the topics covered, we're talking about artisan, textile micro enterprises, or sustainable fashion, where the company had just materials and communication needs and needed some literacy there. Hospitality, health care uniforms here in Portugal, for example, pre-consumer textile waste and feedstock in Northern Macedonia. Just to give you a very short overview. If you want more information, you have to read the full report or the fact sheet, as said, just to pick some snapshots here. Further on, Slovenia with, again, micro enterprises here, reuse centers, closed loop upcycling of workwear. Going to Bulgaria, micro enterprises once again here, made to order formal wear. And then the more complex approach with chemical impact, chemical measurement, and environmental impact, including science-based target initiatives and chemistry in Italy. Along with the last case in Spain, where we had a lot of finishing and dyeing processes, and again, science-based target initiatives and decarbonization strategies. This might seem very chaotic, a lot of companies, a lot of needs. Let's put some things into a more concrete picture and see how we grouped their needs assessment and how we reached some kind of outputs and some kind of recommendations for the future. So the key outputs of this mentoring program, they were grouped in 6 recurring classes. So we had 6 different outputs, starting with baselines and measurement systems. So the purpose there was to turn sustainability intent of the company into quantified evidence. So we had quantified material flows, energy emissions, waste baselines, reported, KPI frameworks and monitoring dashboards, footprint calculations and benchmarking in order to enable a prioritization and investment ready decision and performance tracking. So this is about baselines and measurement systems which were applied by our mentors. Then we go further to the governance and management systems to convert sustainability commitments into more operational routines and more hands-on and tangible routines. So we defined here roles, responsibilities, and governance structures, inventories, procedures, and compliance workflows, internal policies and management routines to establish repeatable sustainability management practices. Further on, pilots and implementation artifacts. Very important, we had a lot of micro enterprises or startups which had one idea, one pilot, something to produce and scale up further on. So they needed a lot of information and a lot of help. So we wanted to reduce the risk by testing circular solutions. So we had pilot concepts and prototype development on a theoretical way. Feasibility studies and costed operational options, technical documentation, and pilot evaluation through indicators, just to generate proof of concept signals and implementation readiness. Then, very important, in order to reach some kind of output or some kind of result, roadmaps and execution planning. to move from ideas to structured implementation. Strategic roadmaps and action plans, of course, were applied. Implementation steps, ownership of data sets, for example. What about extended producer responsibility or digital product passport, which was requested? Milestones, phased timelines aligned with organizational capacity to create clear sequencing and accountability for execution. And then compliance and regulatory readiness, because it was very important for companies to translate regulation into practical operational steps. A lot of companies, especially the very small ones, they heard something about DPP or ESPR, but they did not have any knowledge or any capacity to put things into the right order. So DPP, ESPR, preparation pathways, compliance checklists, and required data fields, guidance on eco-design, traceability, and reporting were provided in order to enable low-risk compliance and regulatory preparedness. And last, it was the ecosystem and partnership activation. So people wanted to sell their things, wanted to maximize somehow the impact, or to increase somehow the revenues. And so ecosystem and partnership activation was very, very important to unlock circular value through collaboration. It's not only about the revenues, it's also about sourcing new materials, sustainable and circular materials. People did not know how to, where to source, where to participate when it comes to fairs and exhibitions. So simple things for us can be complex for other people. Partner mapping and stakeholder ecosystem analysis, industrial symbiosis, opportunities and collaboration pipelines. So we had 3 companies in Spain, for example. So they clustered through their mentor, and selling, one was producing cotton dust or cotton powder, which was used in another company for nonwovens, for example. So industrial symbiosis opportunities and collaboration pipelines, cooperation models across companies, municipalities, and recyclers, especially if we are talking about extended producer responsibility here. And the value created was to create new circular value chains and resource synergies. So this was the clustering about the outputs, just to have an overview, of a snapshot, as said. What changed? Decision grade outputs. I won't go into details. As said, some reports were very much based on matrix. So there was a benchmark and a baseline, especially here, the Spanish case here, it was a bigger company. I think it was Mayoral, Science-Based Target Initiative, and the decarbonization strategy of a company. How to elaborate a roadmap, a 10 years roadmap, product footprint calculator, and the roadmap itself. Let's go to the territory, to the territorial snapshots here and see what has been done in each country. Well, to say all territories address sustainability and circularity, of course, it's not difficult to address or to demand something in sustainability and circularity because it's a very broad definition. Anyway, the mentoring focus and the maturity of outputs differed. Yes, the focus differed depending on the company size and on the maturity of the ecosystem. So if something is necessary, then you have often to contact various stakeholders around, some producer, some manufacturer, for example. Often, if it comes to more sophisticated approaches like recycled content in some specific domains, it can happen that it's not available in their own country, so you have to contact someone abroad. So let's see what has been done in these territorial in this territorial approach or in this territorial result. So in Italy, we had a lot of focus on measurements and management systems, as said, measurement, emissions and chemicals, chemistry. Spain, industrial diagnosis and decarbonization strategies. Portugal, training-driven implementation planning. Greece and Bulgaria focus on SMEs and micro companies for pilots and compliance readiness, DPP, for example, certification. Slovenia, microscale prototypes and reuse pathways. and Northern Macedonia decision support studies and compliance guidance, mainly on post-industrial waste and not that much on post-consumer waste. What consistently improved implementation readiness? Very quickly, and I think I'm over time here. Diagnosis first, then solutions. Okay, structured diagnostic accelerated prioritized action is key here. Data availability is the main bottleneck for certification, footprinting, and management systems, especially when we are talking about small companies. Outputs should match maturity. Low burden tools for SMEs. So it's not, it's key to have a mentor which is very well experienced, but the thing is the mentor should deep dive into the needs of each company. So if it is a company which is a micro one with 1 or 2 employees which are doing everything, then the mentorship can be a tricky activity, because we need some tools which are not very resource or time consuming for the companies. This is the key here. So low burden tools for SMEs and auditable systems for the bigger ones, for the industrial firms. Pilot first logic reduces risk, yes. Define evaluation variables and keep pilots small and measurable. Synergies are not automatic. Feasibility depends on material compatibility and market constraints. And then, of course, regulatory readiness is valuable when translated into concrete actions, like checklists, like data fields, governance steps. The final conclusions, I will read only the titles, and then we can finalize this presentation. So what to preserve and scale when we are talking about final conclusions? Make baselines the default. Quantified baselines convert narrative into trackable performance and credible decisions. Operationalize regulation. Compliance readiness matters most when translated into data fields, checklists, and governance steps. Prioritize governance infrastructure. Rules, routines, inventories are the strongest durability signal. Pilot-ready artifacts show real change. Prototypes, feasibility offers, and pilot designs are clearest operational traction indicators. And of course, reduce implementation risk. Make the next step concrete, costed, and of course, time-bound. In our case, it was a mentorship which lasted for 2 months, which is definitely not enough. Usually a mentorship lasts like 6 months, because you have diagnostics, you have working documents accompanied, you have homework, and often there's also the ecosystem building. When something is required, you have to contact the manufacturer. If he is in your place-based ecosystem, it's fine. If it's national, it's also fine. But if it's abroad, then it can be time and resource consuming. Recommendations, and then I will close the presentation. Standardize early diagnostics, plan for data ownership, pilot with evaluation variables, and add follow-up after mentoring. This is what just I said. To close validation cycles, testing, certification, stakeholder dependencies beyond the mentoring window. So in our case, the mentoring window was very short. I said 1-2 months in total, but stakeholder dependencies, testing, and certification is something which needed more time. So this concludes my presentation. I thank you very much. Not sure if you're still there.
Yes, of course, we're still there.
Okay, oh, thank you. I did not have any visual.
Yes.
I was focusing on the presentation, so I did not know about faces and
No, we're
reactions.
still here, and we're also still more than 2 people. So
okay,
no, you had an audience.
Thank you very much.
Thank you for your presentation, Valentis. And yeah, do keep posting your questions in the chat if you have any to him, and then we can address them after the second and final presentation of this webinar. So now it's my pleasure to welcome Erik, Macias, Simeon from IETEX.
Oh, hello. Thank you, Tila.
Hello.
Thank you
Hi,
very
Erik.
much.
So please take the floor.
Let's go try to share this. Is that okay?
Yes,
Sure.
looks good.
Okay, great. Well, Good morning, everyone, and thank you, Tila, for inviting me this and the ecosystem group and also the Textile ATP for conveying these excellent insight series. So I'm Erik Macias from ITEX, and I'm here to share the progress of the Life POLITEX, our efforts to achieve these fiber-to-fiber full circularity in the textile sector through these novel polyester recycling technologies. I think it's a very good moment to talk about. Well, we are far enough into the implementation to move from this concept to real industrial lessons. Okay, now it's changing. Okay, the Life POLITEX is it's funded under the Life 2023 through Circular Economy and Waste. It's a 42-month project across Spain, Portugal, and Italy, with a budget of a little more than 5 million. 60% of it's co-funded. ITEX is the coordinator, and we have partners like Coleo, which with associate entity TRUSTex, Selenis from Portugal with the affiliated entity Celped, and Selenis Europe and Antex. This way we cover the full chain from textile waste into the creating of new yarns. Our mandate is to prove that polyester from textile can be chemical recycling and responding to textile grade yarn cost effective at pre-industrial scale. So to properly understand why Life POLITEX is needed, it's important to look at the system problem that I think a previous project has mentioned. Behind this textile waste, the textile industry still follows a predominantly linear model with a very significant environmental footprint. In 2020 alone, the sector consumed a little more than 93 billion cubic meters of water and generate around 1.7 billion tons of CO2. Then when we look at this waste management, the picture is equally worrying. Only about 22% of the textile waste is collected for recycling, while the remaining 78% is still either landfilled or incinerated. This leads not to only loss of value material, but also around 92 million tons of textile waste generated every year. And the release of these is approximately 1 million tons of microfiber into the ocean. For an example, a recent survey of 90 major fashion brands show that 80% of them intended to increase the use of recycled polyester. Mainly, these are PET. However, and this is a key contradiction, most of today's recycled PET comes from plastic bottles, not from textiles. This means that we are diverting material from one sector instead of truly closing this textile loop. In most part of Europe, textiles waste is still downcycled into low-value applications such as rags, insulation, or filling materials. Less than 1% of the textile waste is actually recycled back into new products. So our strategy has been to explore these challenges by reuse, redesign, mechanical, thermomechanical, or any recovery. Let's see what. Well, here is what we actually demonstrating in every location. At Coleo, we are trying to reach at the end of the project these 4,500 tons per year of textile waste to be able to separate these 1,755 tons per year of polyester rich. That's our target fraction, and this fraction will go to Selenis, where it will be depolymerized to highly purity BHET and then repolymerized to recycled PET. Finally, Antex will spin these recycled PET into hopefully around 550 tons of recycled yarns. This is not just a lab story. It's real waste, real plants, and real outputs. Too quick. Okay. Now that I've shown you a little bit of the value chain and the process, it's important to be clear about why fiber-to-fiber recycling of polyester textile is still not the mainstream. Why isn't everyone doing this already? I try to summarize it in 5 reasons: heterogeneous feedstock, depolymerization efficiency on the degraded PET, the energy cost ratio of the recycled PET quality specs for spinning, and the scaling beyond pilots. So operationally, we sort, shred, and agglomerate the textile feedstock, focusing only on these 90% rich content PET. Then we apply this chemical depolymerization to break polyester into monomers, move through purification to remove dyes, finishes, and degradation products, and finally the repolymerization into recycled PET with properties comparable to the virgin PET, which is the main goal at the end. But to be honest and transparent about why chemical recycling textile is very hard, we are trying to make it work through first these sorting technologies to be able to separate it and be able to enter this pretreatment, to be able to predict this input into the agglomeration. Then we have to really tune these depolymerization and polymerization reactors with the real waste, not from bottles. And right now we are at the stage of these validation pilot scales of 50 liters and the validation of the pilot scale at 5 liters for both of them. And we are working on building these 2 industrial scale pilot plants. By the end of the project, in addition to achieve this circular system of polyester-rich textile, as I mentioned previously, which is the goal, we are hopefully be able to recycle these 4,500 tons, be able to reduce these 9,000 in CO2 per year, be able to produce the 500 tons at the end, and then hopefully reach that scale up with the cost effective to be able to really introduce this recycled PET in the industry with a very high purity. But we have several problems. The complexity of these post-consumer textile waste with the different blends, different accessories like buttons, zippers, labels. It's very contaminant, so it's been very hard to be able to fully separate everything. Then the efficiency of that depolymerization process, along with the cost and the energy consumption. While chemical recycling enables this recovery of high quality monomers, it is very energy and resource intensive. So we are not reaching the full price that we want to, and we are working right now on that. And at the end, obviously, the recycled polyester, the quality, it's getting there, but we're still working on it. And the scaling limitations, while many chemical recycling technologies are still at pilots or demonstrating scale, scaling up to these full industrial levels requires a further investment and technologies. And we are fine-tuning these processes right now. Hopefully, as we advance, it will be easier, and hopefully we can actually reach the end goal. And part of the project, it's all at the end, we should be able to fully implement in northern Italy by 2030 a second fully scaled plant. Hopefully with this, we will reduce a capex by 20% with the technology that has been implemented for the depolymerization and polymerization. And by these, we will increase the textile waste treatment and recycling capabilities. And yes, which is a very important goal for the transferability of these live projects, is that at the end, after 5 years of the project has ended, that you show that it's also a solution to be applied in different sectors. So we are working to fully apply in some automotive and food processing technologies to be able to use this recycled PET. Hopefully I didn't run too. No, I'm on time. Yes. So if you want to find any more information about the project, you can always go to the ITEX page or any of our social media channels, or you can send me an email and we'll Thank you. Thank you very much for your attention.
Thank you very much for your presentation, Erik. And yeah, sharing more about the Live POLITEX project and where you stand and what you still have planned for the next months. So yes, we're actually caught up some time, so that's great. I invite still everyone here to ask questions now to Valentis and Erik in the chat. So far, there is one question by Robin, to you, Erik, whether you are also looking into other sorting technologies to identify contaminants before the depolymerization stage.
Yes, yes, we are looking in different technologies. Yes, I know they are.
Okay, yes, it's a big team working on that.
Yes, yes.
Okay,
I
great.
can, yes, sure. That's okay.
Okay, yeah, and I think if there are also more questions, well, you shared your email address, and I think Valentis shared his as well. So if any questions come up afterwards, you can also reach out to our speakers, I believe. So if there are no more questions, I'm having a final look at the chat, but there are none at this point. So I will bring up my own slides again to wrap up this webinar and point out some upcoming events for everyone that is still here. So second. Because, well, we have a wide network of many different interesting projects that organize different events. So we actually have like the CISOTAG project webinar on digital product passport and digitalization and textile sorting on the 9th of March, to which you can register. The next ECOSYSTEX Insights Series will take place on the 17th of April. The Pro Planet project is part of the Coatings 2026 conference in Athens in Greece in mid-April. And then there is the Solstice event on scaling textile repair and reuse in European urban centers and its systemic levers on the 5th of May. My colleague will also drop a link in the chat to where you can find all these different events on the ECOSYSTEX website, so you can find more information and register to them. And yes, there will be a skills-focused ECOSYSTEX Insights Series on the 21st of May, and then the Just Fashion project is organizing a webinar on closing the loop with technology on the 27th of May. So yeah, lots of different interesting events coming up this year still. If you do not yet follow ECOSYSTEX on LinkedIn and YouTube, I invite you to do so, because they will also regularly share our member projects, news and events. Same with the mailing list. You can also have a look at the ECOSYSTEX website to find all the different member projects, the publications they shared, the events they shared, and well, the direct links to their websites as well. So it's a great resource pool, and yeah, because our aim is really to sort of have ECOSYSTEX as a go-to platform, so you can easily find all the important and valuable work that is going on in these EU-funded textile research projects. So with that being said, we're coming to a close of this webinar. I would like to thank all our speakers again for their time, answering the questions and sharing what they've been working on in their respective projects. Wishing you a lovely weekend ahead, and yeah, good Friday afternoon. So thank you again.
Thank you for the organization. Goodbye.
Thank
Thank you,
you.
everyone.
Goodbye.
Thank you. Bye-bye.
Bye.
Bye.